The global app marketplace is blooming, and new mobile apps or web apps or desktop apps are being developed for critical applications. And in parallel to this, there is an ecosystem of the clone or fake application is also growing. The clone apps which mimic the genuine apps and phish or scam the users is a new practice and has to be concerned by the security concerns. We can identify the key features of the clone apps as they get successful. They have the perfect UI replica of the genuine apps. Those mimic the legitimate app down to the pixel level precision. This is the very important or the key factor that helps to gull the users. Additionally, there is multi-layer obfuscation hiding the malicious code, and runtime code injection which bypasses the installation time scan, and the stolen developer certifications, those enable the official store distribution. So these are the some of the characteristics which make the clone app successful, and this is the key problem or challenge that we have to develop a system or tool that should filter out the clone apps. Our solution creates a cryptographically secure fingerprint for legitimate apps during the development using the proprietary multidimensional analysis technology. And there is two-part system. One is the developer SDK that can be used by the app developers during the development, and this SDK gathers the DNA fingerprinting or the specific fingerprinting that is the intrinsic characteristic of the genuine app. And this fingerprint based on the ML models is very accurate, and this fingerprint can be used in public domain to check whether the app is genuine or not. And hence there is a front end app, or another part of the solution is the scanner app. It is the public app. The public can, or general users can use this scanner app to check whether the apps available there uh, have the developer fingerprints, the genuine app fingerprints, and before installation those fingerprints can be checked. So this is the two component and simple solution, the developer SDK at the backend or during development, and the scanner app in public for general cross check of the genuine app. The key differentiators or the proprietary advantages of our solution are like: we have designed the comprehensive fingerprinting that includes the static signatures of the during app development, of the code, the resources, package info, etc., and the dynamic behavior pattern, the UI interactions, API uses and network, and the runtime integrity monitoring. So based on these three factors, the very comprehensive fingerprinting is done. And another differentiator is the app specific encrypted SDK keys. So not any random developer can use those SDKs. Those SDKs are issued for the specific app development, and those are encrypted with very strong hash. Hence the developers also can't mimic the SDKs or the fingerprinting itself. So this is the extra layer security we get from cloning. So not only the app can be checked whether it is cloned or not, but also not any developer gets the capability to make an app. So this is the also an advantage. And another differentiator is the cloud-based ML verification. We use machine learning code deployed on the backend or cloud that enhances the verification algorithm. The developer SDK has very small fingerprint, less than 100 kilobytes, and 5% performance impact. The cloud infrastructure will be chosen to have more than 99.99% uptime, and the scanner app will be ML boosted device, and the API performance will be less than 15 millisecond for the single verification time. The competitive advantages include the comprehensive protection, low resource footprint, zero knowledge architecture, cross-platform support, and the seamless developer experience.